Hello and welcome to section 6, counterfactual queries. Back to our roadmap, we saw that Bayesian networks can answer probabilistic queries, CBNs can answer intervention queries, they can also answer identifiable intervention queries without actually performing the intervention. And here we want to show that SCMs can answer counterfactual queries. I start by coding from Perl. While driving home last night, I came to a fork in the road where I had to make a choice. To take the freeway, x equal to 1, or go on a surface street named Sepulveda Boulevard, x equal to 0. I took Sepulveda only to find out that the traffic was touch and go. As I arrived home an hour later, y equal to 1, I said to myself, gee, I should have taken the freeway. I should have taken the freeway means if I had taken the freeway, I would have gotten home earlier. This kind of statement, an if statement in which the if portion is unrealized, is known as a counterfactual. Okay, so how can we model this problem? Let y be the arriving time. Predicting y in the past is a causal inference as we are deciding intervening on the road. So it's really P of y condition on do of x equal to 1, where previously it was x equal to 0. Now the counterfactual problem is asking about the value of y if we had forced x equal to 1 in the past observed event. Not now, not in general. In the past observed event where x was 0 and y was 1. We cannot denote this this query using the standard notations. We cannot just say P of y condition on do of x equal to 1 and y equal to 1 and x equal to 0. You see there's a clash. So we need a different way to write this, and this is the notation. There are other notations as well. This is one. A counterfactual inference, y of x equal to 1, that is like the probability of y when we force x to be 1, given the observation x was equal to 0 and y was equal to 1. So this means that given this event that has happened in the past, what would have happened if we instead would have forced x to be equal to 1? Okay, so this is the freeway driving time in our example. How to answer that? Here's an example. We have seen this in the previous sections, the COVID cough drug example. We have the full SCM. The question is as follows. We observe an individual who was not infected with COVID but was coughing and took drugs. Would the individual still take drugs if they were infected with COVID? To answer this, we first look at the evidence. The evidence is C equal to 0, O equal to 1, R equal to 1. So we can compute the corresponding realization of U at this event. This is the key. Since I have SCM, I can go back, I can plug in these values into my equations and then correspondingly obtain the U of the exogenous values. This is impossible in any of the other layers like the CBN or BN. So how can I do that? Well, I start by C equal to 0, so therefore UC should be equal to 0. From the second equation, O is 1, and UC and C is 0. So from here, I can conclude that the second case is in force. So therefore, U of O is 1 as well. Okay, now for the third one, I know R is 1, so the otherwise case is happening here. I also know that O is 1, so it should be that I have O equal to 0, O equal to 1 and UR equal to 1. So UR should be 1. Okay, great. So I obtain my U values. This is like, it's telling me that this stochastic process in the past, which I cannot say before and I cannot say these values at the current moment, but in the past, because I had this observation, I am able to determine the exact realization. Okay. Now, step 2, well, perform a do on COVID. So back to the graph, I have to do the intervention on COVID. So U of C, that will disappear, and I can plug them into the equations. So I want to calculate the output in the mutilated network, R of C equal to 1 given the observation. This is another way, by the way, to write down the probability for the counterfactual. So how to do this? Well, this time I have, first of all, C equal to 1. I'm forcing C to be 1. So I will remove the equation, replace it with this. And then I will move to the next part. I have to calculate the value of O. I know U of O is 1 here, and C is 1. So it's not the second one, it's the third one. So we will have 0. The value of O will be 0. The third one, I have U of R is 1. I have O is 0. So I will be at the second case. So R will be 0. So the value of R I was looking for would be 0. The person would not take the drug. Okay. This was an example where there was only one direct cause. What if there were several direct causes? Same story. I'm putting it here for you as another example. In this SCM, there's a study time, homework, and score, and the equations are as follows. And you can come up with a story for these variables. T is the amount of time a student spends studying. H is the amount of homework that is completed. S is the student's score at the exam. Now, U of T is the student's free time at home. U of H is the student's intelligence. And the exam is in a way that it only depends on the student's anxiety, okay, as an exogenous variable. Great. So imagine that we observe T equal to 0.5, H to 1, S to 1.5 for a student. The question is, what would the student's score have been had she doubled her done homework? Okay, we may face this question often. Would I have done better if I had spent more time doing the homework? Okay, let's see if we can answer this. We have the evidence. We need to compute U. How? From the equation T equal to UT, we just get that UT is half. From the second one, H equal to this, I plug in the value of T and the value of H, so I can get U of H. And similarly, I can get the U of S here. So I have all of the U's, then I apply the do operator on homework. That means that it will be mutilated and the value of H will be 2 because it should be doubled, right? And the third step is to compute score from this network. Quite straightforward. It will be I need to calculate it from this equation here. And by using the fact that homework is set to the value of 2, right, here, and I know the value of T and US. So I can use them, I can calculate it, and then I will get 1.9. The previous score was 1.5. So yes, indeed, the score would increase. Great. To summarize, in general, we can use these 3 steps known as abduction, use evidence to determine the values of U, action, modify the model by removing the structural equations for the variables in X and replacing them with the appropriate functions, prediction, use the modified model and the value of U to compute the value of Y, the consequence of the counterfactual. Great. Roadmap. So yes, we can answer these counterfactual queries using the SCM by the abduction, action, reduction. Thank you for your attention.